Okay, let's go ahead and get started. Everybody here? Yeah. Afternoon, everybody. Almost afternoon, everybody. Hello? How many of you were in my previous session, out of curiosity? How many of you were not? All right, you guys got to leave. I'm just kidding. Welcome to Case of the Unexplained. My name is Mark Russinovich. This next 75 minutes, I'll be taking you on a tour of troubleshooting. This is the outline for the presentation this afternoon. I've divided it into symptoms, and we'll take a look at specific cases that meet these kinds of symptoms and look at how to solve them. I'll start, of course, with an introduction that will level set what I hope you'll take away from this session this afternoon and what I'm going to try to teach you and share with you. Let me get an idea of how many people have maybe already familiar with the Case of the Unexplained series. How many people have been to a previous Case of the Unexplained session before? Okay, looks like about a third of you. How many people have been to more than one before? More than 2, 3, 4, 10. Okay, because there haven't been 10, so I was just checking. So good to welcome you back. And the reason that you can see people have come more than once is because everyone is different. This is the 2013 edition of the Case of the Unexplained. And while a lot of the core concepts and the tools and features that I cover are the same as I go through each one of these, the cases are all different. So I've actually got collect cases that people send me of them troubleshooting or some friends troubleshooting. I get my own troubleshooting cases, and I put them in PowerPoint presentations. I've got 9 PowerPoint presentations, and the only reason that I cut a new PowerPoint presentation is when the previous one has gotten so big that PowerPoint can't deal with it anymore. I've literally got thousands of PowerPoint pages of cases, and so when it comes time for another TechEd, I go through and I find cases that show kind of interesting techniques or tools or ways of using the tools or just cases to share with you. And that's kind of fun, is because it makes it relatively easy to create a new case every time. Now, of course, all of the cases in here, or almost all of them, are based on the sysinternals tools. Most of you have probably been to sysinternals.com. If you go to Mark's webcasts down here, you will find the previous Case of the Unexplained sessions right here. So these are all the ones that, previous recordings. Every one of these, like I said, has different cases, and some of them even use different tools. So if you find this useful and interesting and want more deeper cases, you should visit this and find more. Speaking of sysinternals, I'll come back to that in a second. If you do have a case, like I've said, a lot of these are sent to me. So if you run into one, please submit it. Anybody in here have submitted a case to me before? So if you, no, nobody? Okay, well, please do if you run into one. Also my blog, actually I should mention that. If you go to my blog, which is right here, a lot of cases, including some of them that I talk about here, are in my blog. And when they're in my blog, they're going into even more depth and detail about how exactly these cases were solved than I do in a presentation like this. So that's another place to go and take a look at cases. So the reason that we've got this kind of session is that most applications do a really kind of poor job of explaining what's gone wrong when something goes wrong. And the reason is, I really don't fault developers that much, because developers have a hard enough time developing their features and making sure they work on their test systems and their dev systems and in their beta programs. But most of the time, those environments are pretty self-contained and self-controlled. The registry keys are set the way they're supposed to be, the ACLs are set on the files appropriately, and so the software executes as the developer intended. What happens, though, when they let it out in the wild world is it runs into other software, and it runs into ambitious systems administrators that go and say, I need to go lock down this machine, I need to go and install this antivirus, I need to go install this other software package, and they run into configurations that they didn't anticipate. And so what will happen is, for example, if an ACL is set wrong on a file that it never expected to not be able to access, the program might not even check to see if the file opened when they call the open function. And so they say open file, which actually fails, and they proceed and say read from file, And that fails, and then they take a look at the buffer that they expected to have some data in it, and that buffer is actually full of garbage or empty, and then the program falls off the end of the cliff, and it ends up maybe at that point crashing, hanging, or giving you a bogus error message. A bogus error message like unknown error, which is my favorite error message. Has anybody seen unknown error before? Yeah, that's just fantastic. And then it says OK when it's really not OK. I don't know why you're forcing me to say OK, so I try to find a way to kill that dialog box without acknowledging it, which I turn to Process Explorer for. Now, so lots of different symptoms, and what the purpose of this talk is to show you how you can look beneath the surface of these problems, to look at what might be causing them, to look at what's the source of that unknown error dialog box. Did it run into a permissions problem? Is there a DLL that's missing? And be able to troubleshoot it that way. So I'm going to show you how to interpret file system, registry activity, and call stacks. Call stacks are one of the key troubleshooting tools in the troubleshooting arsenal. Because many times an operation that fails or is causing a problem for a particular process is not the fault of the process, but something loaded within the process. And so you look at the call stack and you'll see a third-party DLL sitting right in there, interfering with the process. Or you might find the name of functions if you've got symbols loaded, which I'll talk about, that just give you hints about why this thing is failing or why it's querying this registry key that can be a clue to help you find something else. So the purpose of this isn't to give you a formula of follow step A, B, C, and you'll solve the problem. That's just not impossible. There's just so much diversity. Systems are so complex that there's no such formula that would ever work in the general case. It is rather to arm you with, hey, I know about these tools, I know about these techniques, and now I can go and look for clues. And it's all about clues that can lead me to the source of the problem or the probable root cause. And at that point, either address the root cause, and that might mean uninstalling the software, going and getting an update, or disabling it. It doesn't necessarily mean fixing the problem, because a lot of times fixing it is out of your hands. If the software is problematic, it's buggy, and it just won't work in your environment, you're kind of like stuck at that point. And so you got to decide, basically I got no choice if I want to not have those problems show up, but to delete the thing. The tools we're going to use, like I said, are predominantly sysinternals tools, which are totally free for download. You can actually download them all as a bulk package here. If you go to sysinternals suite, this is one big zip file. You see it's 13 meg for the entire suite of tools. And you can see this is all of the list of tools right there in one package. There's also live.sysinternals.com web share, where you don't even have to download it. It's actually right here. You can go to the website here, hit it in a browser, and you'll see a directory listing with all the tools. Or you can hit it using the WebDAV share and launch the tools from the WebDAV share without even having to download them. By the way, this tool that I'm using is called ZoomIt. And ZoomIt is also a sysinternals tool. And it can do a bunch of things like draw squares, triangles, rectangles. You can change colors. You can change the screen background to black, and then draw there and make a smiley face if you want to by making a circle, because there. So oftentimes I'm on the airplane messing with, yeah, thank you. Didn't expect applause on that one, but I'll take them. But the other tool that I'm going to show you is called Debugging Tools for Windows. And you can see it's also known as WinDebug. There's the free download to that. You have to download the SDK, and then you can select just WinDebug or the DDK, the WDK Windows Driver Kit. And that's the link to go download it, also free. There's a book that I'll plug here, because if you're interested in these tools, then you want to really become an expert at them. The Sysinternals Administrator's Reference, co-written with a colleague of mine, Aaron Margosis. How many of you went to his primer yesterday afternoon? So quite a few of you. So you can see that, what happened there? You can see that his name is here on the cover. He actually, he did enough work that he actually convinced me to put his name on the cover eventually. So he likes to make fun of the fact that his name is small, but he's lucky that it's even on there. So. And it has full chapters on all the major tools, in-depth references, plus it has cases at the end of the book as well. So let's get started. Let's talk about sluggish performance. And before we get into this section, there's the number one sluggish performance troubleshooting question that you ask when you run into some situation where the system's behaving sluggishly. By the way, how many people have run into a sluggish Windows box before? How many people have never run into a sluggish Windows box before? Yeah, any Mac users in the house? Yeah, so the number one troubleshooting question is, are you running Windows Vista? No, that's just kidding. It's not. Windows Vista is actually, Mark Manassi gets mad at me every time I say that. Mark Manassi likes Windows Vista, but he's a special kind of guy, I guess. So. Sluggish, so let's talk about sluggish performance. This case was actually sent to me, and it's a really interesting case because the ones that are most interesting to me aren't just the bam, ran the tool, boo, there's the problem, but ones where they had to investigate deeper and deeper and deeper to get to the root cause. And this one is a great one for that. The situation was Explorer was, when they opened up Explorer, it would take a very long time for Explorer to refresh the files in the folder view. So the first thing they did was capture a process monitor trace. How many people have run process monitor? How many people have not run process monitor? Anybody not run? Nobody, one person. Just one person has not run process monitor. Really? That's okay. Okay, I don't believe you, but process monitor is a real-time file system, registry, network, monitoring, real-time monitoring tool. I'll fire it. Oh, and by the way, process monitor, if you look at all my cases, those hundreds of cases, the vast majority, probably 80% of the cases are solved or partially solved or contributed to the solution is process monitor. It's led, Dave Solomon came up with this slogan. If you were in my previous session, you've already said it a couple times. But this slogan is appropriate because there's so many cases where even somebody sends it to me and I look at it and I'd say, oh, I'd use Process Explorer for that. And what they did is ran Process Monitor, and Process Monitor helped them solve the case. So the answer is, when in doubt, run Process Monitor. And when my daughter comes home from school with homework, I make her run Process Monitor first. But it's such a useful tool for troubleshooting that I think I'd like you to embrace that slogan. And I think by the end of the session, you'll be convinced that it's worthwhile saying it. But let's start, and you'll just have to trust me, and then we'll get better at saying it. So, and I think maybe we'll pit the room against each other to kind of get some competition going. So how about these two rows? Let's say it. When in doubt, run Process Monitor. Ready? 1, 2, 3. When in doubt, run Process Monitor. All right, middle. 1, 2, 3. When in doubt, run Process Monitor. Right, this side. When in doubt, that side, forget that side. All right, so let's pull up Process Monitor and take a quick look at it. For those people that I know that are lying by not raising their hands, that have not run it. The first thing you'll see is just it spews, starts to collect real-time output. It divides it into columns. We've got a timestamp column on the far left. The next column is the process that is actually emitting the event. You can see Explorer here. The next column is the process ID. Then the operation. Here's a query name, query information file, name file. Here's the target path. So for a file operation like this is, and actually this little icon tells you it's a file operation. This is the path of the file, the result of the operation, and then other properties. So this is what came back from that query information file operation. There's registry queries you can see here, and you'll see registry values come back from registry queries. And let's see, I don't see any registry queries. Here's one, a registry query. So you can actually see the data that came back, regsz, and it was a string 137 whatever that came from this modern mix last update check application. That's the basics of Process Monitor. One of the enhancements that I've added almost at the request of Microsoft support people is when they capture Process Monitor log files and they send them to each other, that they like to set bookmarks to say, highlight specific areas in the trace that they come back to. And so I just pressed Control B, and what I've done is created a bookmark If I go back to the beginning and I say F6, I get taken to the bookmark. And when I exit process or save this file, the bookmarks get saved with it. In fact, I can load a saved process monitor file and add bookmarks that will get saved automatically with the file. So it's a feature that's relatively new. Let's get back to this case now, and we'll dig into some more of the features as we go. In this case, what they did, let me pull up the file that they ran into. Let's freeze this output. They captured the process monitor trace, and here's the file. So what they did was scan through this trace, and you can see that some blue colors went by. Actually, I set a highlight filter just to demonstrate something, demonstrate highlighting. But they scanned through it, and this is one of those cases where a lot of times it is a matter of just going through the output and looking for something that might provide a clue. They've already set a filter for just Explorer, so you can see we only see Explorer activity. And the question is, what in here could be a clue for why Explorer is behaving sluggishly? They spent probably 20 minutes looking through this. I'm going to just F6 right to the bookmark that they saved for me for what led them to the clue of the problem. And it's this create file right here. Because when they saw that, they immediately knew what was going on. Is this thing is pointing off at a network share that didn't exist and causing the sluggishness. I've got a similar situation that I've recreated here. Whoops, I've recreated. That will be a very sluggish performance. If I type Notepad in this command prompt, that's literally going to take minutes to launch. And if I come back, let's see if I can see what happened here. What command.exe is going to be doing, and we're going to start to see the output of this, which is going to give us the clue in probably 15-30 seconds, is the actual answer for why this command prompt is taking so long. So we're going to come back to that. But so it's a variant on this sluggish Explorer case that this person solved by looking for those name not founds. And what they did was said, okay, why is this, the next question is, why is it accessing that network share? And what they did was take a look at their home drive settings and the account mappings, and you can see that here's the home drive setting right there, pointing at that network share. And here's the mapping that they saw in Process Explorer, which I'll come back to in a second, that confirms that Explorer, because that was the home drive, this non-existent network share that was set up for this particular account, that Explorer had set the current directory there, so every time it was looking for icons, it would go and try to search for this particular place on that network share, as we saw in the trace. Let me see how that command prompt is doing. Now look at what it's doing right here. It's looking for a non-existent network share, and it's timing out. And here's the client-side caching, where it looked in there and didn't find it. And this is the thing, then times out after a while, and we see bad network path show up. I contrived this just by setting the environment variables of this command prompt, which that Notepad is going to take forever to launch, and then we'll take a look at the environment variables. Actually, we'll come back to that in Explorer and take a look at the environment variables. But there you can see how Process Monitor showed us why that Notepad is taking so long to launch. It's because Explorer is off, or command prompts in this case, is off looking for something that doesn't exist on a network share. Very similar to this example. So what this person did is just to verify that that was indeed the problem, they opened a command prompt, killed Explorer, restarted it from the local directory, so Explorer's current directory was on this local file, this local directory, and then they were able to look at their folders, everything populated very quickly. So they contacted IT, had them change the home drives to existent network share, and then the problems went away. I touched on Process Explorer in that particular case, and Process Explorer is going to show us exactly why this command prompt is taking so long to launch. And Process Explorer is like a task manager replacement. Let me pull it up and take a quick look at what we've got here. This is called the process view. It's got a process tree structure that shows us the parent-child relationship between the processes. One of the ways that you can see how this parent-child relationship shows you how processes are related to each other is here under the Explorer branch of Process Explorer's view. Explorer is my shell. So those of you in the previous session know that when I log in, or when you log in, if Explorer is your default shell, then everything you launch as part of your interactive logon session will be inherited from Explorer.exe. And so all of these processes were launched by Explorer. I will mention that some cases you run into processes like these that are fully left justified. These are processes that are sadly orphaned. They have no parent anymore, which is kind of sad. Their parent has lived at some point, given birth, and then died, exited. And so these guys are now living on their own. We don't really know who their parents are, and so take good care of them. Treat them with kindness. But we can see that their parent process ID shows up in the Performance tab if we take a look at the parent process ID. Actually, where did that go? Parent process ID. Parent process ID. Well, I've lost track of the parent process ID. Did I miss it? Where is it? Oh, parent. There it is. Parent 220. So Process Explorer itself was a parent of Process Explorer. And it abandoned itself at birth. And now Process Explorer is parentless. But that's what you'll run into with the left justified processes. What I do with Process Explorer is I select this option right here. Hide when minimized. I select allow only one instance. I select replace task manager. It's because that's the way that Windows should be. And so what's your favorite way of launching task manager? There's several ways to do it. Control-Alt-Delete. I don't like that way. What's another way? Control-Shift-Escape. I like that way. There's the real task manager. And that's because of that replace task manager. And by the way, I'm not going to tell you how it replaces task manager, but the tools that I'm showing you in this talk, you can figure out how it did it. And it's a tool that I haven't covered yet. So I'll leave that as an exercise for you. One of the other things that I do is I minimize the tray and then I make it visible. And there's been several cases when on my own systems, nowadays it's sometimes very hard to detect a process that's run away with the CPU because we all have multi-core systems. Back in the old days when you had one CPU, if something ran away with the CPU, you felt it because you only had one CPU and suddenly everything was sluggish. Now if you've got a process that runs away with a CPU and you're on a 4-core system, it's burning one CPU, it's draining your battery, but you're probably not even going to feel the effect of it because you've got 3 cores at the ready. So system might not be as fast as it could be, but it's probably unnoticeable. What Process Explorer's tray does, icon here, will show you CPU usage in real time, and hovering the tooltip over it will show us who's consuming CPU. And in this case, I do have some CPU usage. At the time I'm hovering this over, there's one of the service host processes that's burning about 27% of my total CPU. And this is a 4-core system, so that is burning a little over a core of my system. If I did not deal with this, then my battery life is probably going to be cut in half if I let that continue to go. So that I always keep it running there at the ready. Process Explorer, recently enhancements include the fact that it can monitor GPU usage. I'm not going to show that, but be aware that you can go and add GPU columns. There's a GPU view, performance view up here in the, where'd Process Explorer go? Up here in the system graphs right there. This is the GPU graph. And actually, while I'm zoomed in, you can see DWM starts to consume a little bit of CPU because it does use the CPU accelerator to do this zoomed in view, this zoomed in live view. I've also added process timelines and auto start location. So if I add that column, auto start location, this will show us how these processes get activated. It's kind of a merging of Process Explorer and Auto Run's, a tool that I'll show you in a little bit. Let me drag that column over. And I mentioned that Explorer is launched as part of my shell, and you can see that right now here. You can see how these other processes got launched from the run key. This got launched from the run key, run key, run key. I've got zoom it in the run key, link in the run key. So this is useful for seeing how things get started. Here's malware, anti-malware as a Windows service getting launched there. That's a relatively new feature. I also added heat maps. How many people like the heat maps, by the way? So this will show us, get rid of this column. I didn't hear anybody clap. Does nobody like the heat map? Does anybody like the, okay, let me ask this. Anybody not like the heat map? Is there people being quiet? Everybody loves the heat map? Okay, cool. The heat map is also, you see the Windows 8 Task Manager also has heat map. The reason that I asked that is because there's some people in the Sysinternals forum that were like, Mark, we hate you. We're never going to use Process Explorer again because we hate the heat map. And I was like, I don't care. You know, actually, I do care. So what I added is if you go to View, you can say, don't show the heat maps. So I added that for them. So that made them happy, I guess. They liked me again. But what you can see with the heat maps is there's that service host that's consuming the CPU stands out because it's there in a darker green color. And there's another one that's spun up, and that is the zero config service doing something from Intel that you saw show up as a darker green as well. I've also, has anybody do crash dump analysis in here? So one of the problems with Task Manager's crash dump capability, Process Explorer has this too. You can say create dump, and you can create a mini dump or a full dump, that it will match the bitness of the target process. One of the pains is if you've got a 32-bit process and you're running a 64-bit tool like this, that you get a 64-bit dump, and it's painful to go look at the 32-bit view, which is what you're interested in. Now what this will do is generate a 32-bit dump for you. Okay, so that's a quick view of Process Explorer. Of course, I'm going to cover a bunch of the features, additional features as we go along, but that's an introduction and some of the new features if you haven't been keeping up. Here's another case that involved Process Explorer as part of the solution. This one, the system again was sluggish, and the user detected the sluggishness. You can see that in this case, the full CPU was being burned, all of the CPU usage was being burned, and he opened Process Explorer and saw that it was this particular process, ICQ, which is a chat client, consuming the CPU. Now, this is a very popular chat client, so this user doubted that it was actually ICQ's fault and wanted to investigate a little more deeply to see, is it ICQ or is it something that's causing ICQ to consume CPU? And to do that, he needed to look inside of the ICQ process, at the threads in the process. What's the difference between a process and a thread? A process is a container. It's a container that has an address space, so this is the place where the DLLs and the virtual memory get allocated from. It also has a list of handles to operating system resources, like what files and registry keys it's got open. It also hosts a security context, so a process and anything running in it, when it tries to go open a resource, it's running with what's called a token that you can see in Process Explorer that says, I am Mark, and I've got these privileges on the local system. It also, but it actually does not execute code. What executes code are the threads, the execution contexts that live inside the process and that execute the code that's mapped into virtual memory. So to look at what is actually consuming the CPU, you need to look at the process at the threads consuming the CPU. This is especially true in troubleshooting scenarios where you're looking at a process that's a generic hosting process. There's a lot of processes that live their lives not to do something themselves, but just to host things. Service host is one example. And you saw a bunch of service hosts up here in the view. Service hosts are just container processes for DLLs that implement Windows services. And you can see this one's got a whole bunch of DLLs or services loaded within it, each one in its own DLL that implement Windows services. If we saw one of these consuming CPU like we did, this service host has a bunch of services running within it. The question we've got, it's not this service host. It's not service host's fault that CPU is being burned. It's the fault of something inside it. It's a fault of some DLL that has threads executing its code. And so we need to take a look inside. And to do that, we need to look at the threads tab in the process properties. Let's go take a quick look at process properties. And we start with this tab, which gives us general information about the executable image. This tab shows us a bunch of performance information, virtual memory usage, physical memory usage, I/O activity, open handles. This is performance graphs for CPU, private bytes, I/O. Disk and network activity, GPU graph. The Windows services hosted within it. So you're only going to see this tab on a service hosting process or a service process like this one. The threads, I'll come back to that in a second. Open TCP/IP endpoints. I mentioned the security context. Here's who this service is running as, local service. It's login session 3E5. Here are the groups that this user belonged to at the time this process was launched. Here are the local operating system privileges assigned. The environment variables. Oh, and speaking of environment variables, this command prompt, let's go take a look at that command prompt. That notepad finally launched. It's right here. And if we take a look at that launch, oh, I didn't have process monitor monitoring it. We would have seen it there too. But let's take a look at this notepad and take a look at its environment variables, specifically the path variable. And if you look, the path variable has all of those bogus shares at the front of it, which I added just so that this thing would take a long time to start. Processes inherit their environment from their parent. I set the environment variable in the command prompt. So when Notepad finally launched, when Windows was finally able to find it in Windows directory, after it tried looking at all these non-existent shares, then it inherited that same environment variable. And then we've got strings, which is something that's useful for analyzing malware like I did in the previous session. Let's go back to threads and that service host that's consuming my CPU and making my machine kind of hot at this point. And what I'll see is a list of all the threads executing in the process. Let me close this up for a second, because we'll come back to what that means. And what we see is the CPU usage as well as the CPU cycles being consumed by the process. We see the start addresses of the threads. Every thread begins its life at a function that the developer has programmed. And if it's in a DLL that's loaded in a process, the programmer says start the function in this image, this executable, this DLL. If it's a Microsoft image and you've configured symbols so that Process Monitor can go, or Process Explorer can go fetch symbols from Microsoft symbol servers, which you would do here, then you will see the names for all of Windows functions inside of Windows executable images, which can be extremely useful for troubleshooting because you'll see names of functions that can give you clues about why Windows is doing things it's doing. You need the debugging tools for Windows package installed. You can see I've put it up in program files, debugging tools for Windows, because that DBG help knows how to talk to the symbol server, which you've got configured there. And you don't need to memorize this. This is in the debugging tools for Windows documentation. But something you should do for Process Monitor, Process Explorer, and you have to do it for Windows Debugger, is to go configure that symbol server path right there to go fetch the symbols. Because I've done that, and these are mostly Windows executables, I see start addresses that have meaningful names. And this process, there's two threads in here consuming CPU here. One of them has a start address in a DLL that has kind of a suspicious name, Service Hog. This is a service that I created myself just for demonstration purposes that's going to consume CPU. And what we see is that part of the CPU consumption of this service host is this particular service, that Service Hog service. If I go back to the Services tab, you'll see that I was nice enough, if you happen to get this on your machine for some reason, not saying that I spread this thing, but it'll say that it needlessly hogs the CPU as a nice description. And there's where it's located. So it'd be nice if you run into a situation where the start function of the thread actually tells you what it is. In this case, I know it's Service Hog, and what I would do is go find an update for Service Hog or delete that service so that it's not going to be causing me a problem anymore. Let's go see what happened in this case that this user ran into. They took a look at their threads, and unfortunately they saw two threads burning the CPU. That's a two-core system. Two threads fully consuming each of their cores. And the start function is a generic function. Quartz.dll is a standard Windows DLL. And you can see he didn't have symbols loaded at this point. So we're getting some bogus offset off an export function name. But this isn't telling him what's going on. This is something in Windows. He suspects it's not even an ICQ, so he needs to dig deeper, just like we do for this other thread that's consuming CPU. If we go back, this one up here began its life as TPP worker thread, which is a generic system function that is just for executing work items, small work items handed to it by other threads in the process, where the thread doesn't want to do it itself, and it says, hey, you go do it for me. And it tosses these work items at the worker thread pool, and that then gets picked up. So some other thread in this process is tossing junk at this thread, which is just kind of like a hosting thread, and we need to figure out what it is. For that, we need to look even deeper. And I mentioned that call stacks are the core tool for debugging. We need to look at the call stacks. And the way you can do that is by double-clicking on the thread. If you've got symbols configured, then you're going to get a nice view of what's happening. So let's go take a look at this TPP worker thread. And the way that you read a call stack is you start at the bottom. Essentially, we've got a snapshot of where this thread is. And when threads execute, they call one function that calls another function that calls another function. And the way they remember to get back to where they were is they use this scratch memory called the stack. So when this thread began its life, it began here. And then it called this function, stored the return address on the stack, then called this function, and so on. So what we did is we caught it in the middle of this function. That's where it's executing right now. In service hog, my work callback. So this thread is also performing CPU operations on behalf of that service hog service. But we see that because we're actually taking a look deep inside the process at the thread and at the stack. When this thing ever exits that function, it'll return to here, which will return to here, and so on. If it returns from here, the thread terminates. And that's the stacks. What I'm going to do at this point to get this thing out of the way is just suspend these threads, which I can do down here. Suspend that thread, and now I suspend that thread. And now I've quieted down my CPU after I figured out what was causing that problem. In this case, he looked at the thread stack and saw this DLL, videocore.dll. So this does look like a third-party DLL. Question was how to get rid of it, how to figure out what it is, and then how to get rid of it. So we open the DLL view in Process Explorer. What's the DLL view? It shows you what DLLs are loaded into a process and executable images, and as well as mapped files. So some files are mapped as executables, some are mapped as images, and you can tell the difference by saying the mapping type, adding the mapping type column. And let me move this over. And you can see like the locale file is mapped as a data file. This MUI, which is resource strings for internationalization, mapped as data. And then you can see things mapped as executable images. And we'll see service hog in here someplace. Sort here. Here's service hog, right? Oh, am I on the wrong one? I probably clicked on the wrong one. Anyway, if we clicked on the one with service hog, we would have seen servicehog.dll sitting inside that. What he did is looked at the DLLs loaded into this, and he found 4 of them that are all packed. That's that purple color, meaning that they're compressed or encrypted. Oftentimes the sign of malware, but you will run into legitimate software that is packed or encrypted. And one of them has a description and company name. The others don't. So the other ones actually would have been suspicious as malware. This one does have a company name on it that looks like it's a legitimate company name, some demo software that somehow got installed on his system. Question was how to get rid of it. He went to add remove programs, no sign of it. How does he figure out how these DLLs got loaded and get them off the system? For that, he turned to autoruns. How many people have used autoruns before? How many people have not used autoruns before? Okay, so autoruns is like msconfig except a lot better. What it does is shows you every place or hundreds of places in the registry and file system where stuff gets configured to run when the system boots, when you log on, when services start up, when drivers get loaded, when you do printing, when you launch IE. And I've got it configured here to filter a whole bunch of stuff out. What it's showing me are just third-party code, stuff that's not signed by Microsoft. But let me escape this and go to Options, Filter, and turn off all the filters so you can see all the gory detail of everything that it looks at. And you can see the scroll bar thumb is getting really, really tiny. Auto Runs divides it into categories. This logon one is the most closest to what msconfig or Task Manager will show you. Like here's the run key with a bunch of those things that you saw in Explorer, Process Explorer as launched from the run key. Here's Explorer shell extensions, filters, protocol handlers, shell service objects, all sorts of stuff. And you can see third-party things configured in here, shell extensions. Here's IE browser helper objects, scheduled tasks, services, drivers, codecs, boot execute, image hijacks. Well, I'm going to go ahead and tell you the secret for how I take over Task Manager, and it's right here. Image file execution options. There's taskmanager.exe. Sysinternals takes it over with Process Explorer. So every time the system goes to run taskmgr.exe, it gets Process Explorer instead. App init, known DLLs, Win logon, providers, sidebar gadgets, network providers. You can see the list goes on and on. So that's why I have this filter, which lets you focus on just on third-party things. If you want to see all the places it looks, by the way, not all of them are populated. Say include empty locations, and it will show you. You can see there's a bunch of places where there's nothing configured right now. But places where stuff has been configured, generally I only add things when I see malware using them. So this list has gotten bigger as malware has gotten found more nooks and crannies to hide in. And let me pull back my PowerPoint. In this case, the user opened up Auto Runs and disabled all the Viscom DLLs. And I've got his file right here, Viscom sluggish spiking ICQ. And if we search for Viscom, because he just figured it's Viscom for everything, you can see Viscom frame, grabber, audio encoder, and what he did is just deselect them all. This is actually the file he sent me. And so he just deselected all the Viscom, and the problem is solved. He was able then to launch ICQ, no burning CPU anymore. System was in a healthy state again. This next case is one where users at a company started complaining, including executives, that their logons were taking 5 to 15 minutes, and which is longer than normal. And how many people have experienced this at your work? 5 to 15 minutes logons. Yeah. It's kind of a pain when you run into this just to get started. So actually, the IT department's like, oh, whatever, users are complaining, until the execs started to complain. And then it's like, okay, I guess we need to take a look at this. So one admin got assigned this. What is going on with these 15-minute logons? So he tried everything. He's looking at the event viewer for things. He captured Wireshark traces. He's doing malware scans with multiple malware engines on one of these systems that's taking a long time. Nothing. Then one of his friends had come to TechEd and seen this class. And he's talking to him about this, like, how do I solve this? He said, hey, you know what? I learned this slogan at TechEd. Ready? 1, 2, 3. When in doubt, run process monitor. Huh? Okay, we'll try that again later. So he ran process monitor and captured a trace of the logon. Now, how do you capture a trace of the logon? There's a few different ways you can capture traces of activity when it's kind of inconvenient. Like, how do you run process monitor, log off, and then capture the trace? A few different ways. I'll quickly enumerate a couple of them. One is to use psexec. You can use psexec and type SID and then the name of the tool, the program that you want to run. And what this will do is launch it in the system, a logon session. Now what I can do is log off. When I log back in, this thing survives that log off, log on, and it'll reappear on my desktop. And so you can run process monitor that way to capture a log on and log off. You can do it from another log on session, of course. Or you can capture a boot trace. Process monitor knows how to capture everything from log on to shutdown here with enable boot logging. So you can actually capture the shutdown process or the boot process using that. So let's take a look at file that he captured. There's lots of different ways to go about analyzing the data that you capture from a process monitor trace. One of the ways to get a big picture view of what's going on is to go to the process tree, which is what he did. He opened up this, and he looked at the tree of processes that kicked off by WinInit, which is the Windows initialization process that starts very early in boot, and look at all the things that get launched. And what he did is, just after a few minutes, he came across this right here, frame package. Frame network package. Anybody recognize that? Anybody? Well, what? It's McAfee. It's a McAfee installer. See McAfee Inc. And it's dumping off something else, which is then running this MSI exec. So it's installing something. And it's installing something that takes a long time, you can see here. It's actually, he captured this trace because I've asked him to capture this trace. So he didn't actually let this thing finish. He just captured it. So the way that you can see if a process is terminated or not, if it's terminated at the time you open the process tree, it'll be this dark green bar. If it's still running, it's light green. So he captured this trace a little prematurely, so it even takes longer than what we see here. So what was going on? What kind of clue did this give him? Well, the command line, that company name over here, McAfee Inc., gave him the clue it's AV's reinstallation. So his question, he contacted the server admins and said, hey, what's going on with this McAfee antivirus install that seems to be making the thing take so long? And they said, oops, that OU, this new image that we've rolled out isn't supposed to be part of the OU that gets this thing, this package that gets installed every time. The GPU should have been removed after we did our Win 7 rollout. They fixed the GPO. That rolled out. Now users' logins went back to a reasonable 5 minutes, no, whatever. So the problem got fixed with the help of process monitor showing him what's going on. This next section is the section that deals with those bizarre error messages and where they come from. In this case, this is my own. It's always kind of rewarding to solve my own cases with my own tools. I get very excited about that, and I tell everybody for the next few days how I did that, and they get really annoyed with me and tell me to shut up at that point. But nevertheless, it's really kind of fun. In this situation, I was editing a PowerPoint deck, and I tried deleting it. I had a PowerPoint deck that I'd copied someplace else. I was going to delete the original, and boom, I got this. And you can see this is about IaaS. It's actually a screenshot of what I ran into. I'm like, what the hell is going on here? This is the PowerPoint I'm trying to delete off my desktop, and I'm getting an error. And I open up PowerPoint. Actually, I open up, this was a relatively new system, so I open up Task Manager, and Task Manager takes you to this Applications tab. Yeah, and you can see it's not got anything except for that file and use dialog box. So, and you know what? I fixed this problem with me having sometimes Task Manager running, because what was always a pain for me when I get into a new system is configuring Process Explorer to launch automatically whenever I log in. I've got to go and create a shortcut in the run key or startup folder. So just this week, I added this. And actually, it was at the suggestion of Aaron. He's like, why don't you add it? So I did this. Run it logon. And the cool thing about this is I use a scheduled task. If you're running Process Explorer elevated, it'll configure the task so that when you log in, Process Explorer is running elevated as well. And it'll just show up in the tray. So that's now my problem is solved. I never have to see Task Manager again. Now, in this case, I did run into it as like, well, that's a fine use. This kind of demonstrates just how helpful, in quotation marks, Task Manager can be. I had to figure out what's keeping Process Explorer or keeping that file locked. I've actually got a reproduction of that here. If I go and open my Case of the Unexplained folder, I've got a directory here that is taunting me with its name. And look, it's actually right. If I say delete, it says it can't because something's got it open. It doesn't tell me what it is, though. And this is one of the beauties of Process Explorer is it will tell you exactly what's got that open. Can't delete. So it's searching through all of the handles and all of the DLLs of all the loaded processes to look for anything that matches that substring, and here's one of them, Outlook. Why does Outlook have this open? And I just opened up, I just clicked, and now I'm in the handle view. Outlook has got an open handle to this. But I don't see Outlook anywhere here. Where is Outlook? There it is, but it's not active. Where is Outlook? It's sitting over here on my second desktop. This is another SysInternals tool. And I've got it running there just for this example. Because what happens, and I've complained about this to the Outlook team for like 10 years now, is when you save an attachment, Outlook keeps a handle open to the parent directory that you save the attachment into until you exit Outlook or you save an attachment to someplace else. So all I had to do this morning was save an attachment to Can't Delete Me, and now I can't delete that folder because Outlook's got it open. So I actually gave up trying to convince the Outlook people that that was wrong to do that. There's a few different ways you can handle this situation. You can terminate Outlook, you can save to a different place, or you can just say this. Yes? No? Everybody always wants me to do it. Actually, I honestly don't know what's going to happen. This turns red. The handle's closed now, and if I come back here, no, I just deleted it. Now, I wouldn't recommend doing that on your production server, but it can get you past a situation like this on your home system. This next case, this user, actually you can see this user is from South America, not Spain, but if they'd been English, this would have been concerning that the message showed up in Spanish and not English, but that's not the case here. They were Spanish, and you can see, anybody Spanish in here? Any Spaniards in the house? No, just kidding, I figured. How many Spanish people are in the house? Actually, not very many of you. So I'll read this for you then. La tienda Windows no está disponible en áreas de trabajo de Windows to Go. Now, I don't know what that means, but I'm just going to... Actually, I've reproduced this error. Oh, an incident. I'll come back in a second. So if I press Store, look. I'm stuck. So let me capture a process monitor trace to see what's going on. Find my process monitor. Okay, let's do that again. By the way, this is not a disclosure. This is not Windows 8.1. I'm running Windows 8, and this is a third-party start menu. So for those of you that were wondering. So he captured a trace just like that. And then what he did was search through the trace. And eventually, this is one of those cases where sometimes you just have to be patient. He ran across this WWA host, which is the hosting process for HTML5 Windows Store Modern Metro apps. And it's querying this value right here. HK local machine system, kernel control, set control, portable operating system. It's getting back a 1 from that for some reason. So he was like, I wonder why. I wonder if that has anything to do with it and why that is a 1 when this is not a portable operating system that he was on. You know. So here's the key. I just pressed regedit jump to. Set that to 0. And let's try that again. And bingo, we're going to connect to the store. And that's exactly what he did. He sent me this case, and actually he didn't know why it was marked as Windows to Go. So I contacted guys in Windows that I'm friends with. I said, hey, there's this case. They looked into it, and the reason that it's marked as portable operating system is it looks to see if the disk ID of the boot volume is the same, it is external USB drive. It's a USB drive, external media. And when we went back and forth with the guy that had run into this, it turned out that he'd been using some disk cloning software that had cloned disk IDs across volumes. And so even though he was booting off a local Maxtor disk, he had previously inserted a USB key that had the same disk ID as that OS volume. And so Windows just scanned and said, oh, You're actually got a disk ID that it matches something that I saw previously as an external media, so I'm going to treat you as Windows to go and set that flag. The Windows guys put in a fix so that it more reliably detects which is the boot operating system and doesn't conflict, doesn't get confused about these kinds of disk IDs as a result of it. So you shouldn't be running into this problem. But this is kind of a really cool case of process monitor. Again, a few minutes, he was able to solve the problem. So you guess what I'm going to ask you to say. Do you want to say it or not? Or, yeah? You convinced yet? You excited about saying it? No? No, not? Okay. I'll wait. I'll convince you. Will be more cases. How about this one? This one's another one that I ran into myself. Now, you can see that I set my background to Windows Azure here, my lock screen. But what I found, this was really disturbing because sometimes what I do is I take my laptop and I RDP into it from home, and I'm at work, I RDP into it because I got my desktop system, so I'll RDP into my laptop, and then I'll pick up my laptop and take it to meetings. And after I take it to a meeting, the lock screen comes up, and it's the standard Windows 8 Space Needle thing. And I'm like, what the hell? I set the lock screen to this Windows Azure thing, but it's not sticking for some reason. So I think, okay, maybe it's just a bug in Windows. And I proceed another few days, and every now and then when the lock screen comes up, it's showing this standard Windows 8 start screen. So I'm like, what the hell? And eventually I figure out that if I log in interactively and then I lock the system, then I see the lock screen that I configured. But if I RDP into it and then the system locks, I see the standard Windows thing. So I'm like, what is different about those two for where it's finding the lock screen? Guess what tool that I used? So I've got those two traces, one from when I locked the screen interactively, and one when I RDP'd and let it lock. So this one is the one with the correct lock screen, and then I've got this one, which is the RDP version. The question is, why are they different? So the first thing I knew is that all of the lock screen images, including the one that I'd made, were JPEGs. So I set an include filter. This is where the filter dialog becomes interesting. Path, and I said ends with .jpeg. Said OK. It'll remind me that I didn't add it. And then I say the same thing on the other side. And I say path ends with .jpeg, add, and then OK. And now we can start to compare. And you can see the ones on the left, which are the correct one, look at the path where it's looking for the lock screen. It's looking in program data, Microsoft, Windows, system data. This is a SID, which is my identifier for my account, a directory called read-only, lock screen _B, and then it's pulling this image, which I configured as my lock screen, which it had named lock screen __ 1600 by 900.jpg. On the other side, if I go to the end of the trace and look at where it's pulling the image from, oh, sorry about this, all this jumping around. Let me get this configured, and then we'll take a look. All right, program data, Microsoft Windows, so far so good. System data, oh, look at that. S-1-5-18. That's not my SID. That's the SID of the local system account. So for some reason, it's putting it in its profile. Read-only lock screen Z, lock screen 1600 by 900. And I don't know what the Z and the B mean, but that's where it was looking. So I was like, I know how to trick it. I'll just go and put my lock screen image overwriting the one that's there, because I really, really, really want my lock screen to be the Windows Azure lock screen. So let's go see about looking in that directory. Windows can't find it. Check the spelling and try again. Guess what this is? What is that really going on there? Oh, wrong one. Process Explorer tells us that that's a bogus error dialog box. That directory is there. In fact, Explorer goes all the way down and looks at it and gets access denied and then tells us it doesn't exist. All right, now are you convinced? No? Okay. I've got more. So how do we get past that one? PS exec. I already showed you how you can launch things in the system process. I'm in the system process now. And I can say, go into that directory, and now I'm in there. PSExec is a program that normally lets you launch things remotely, but it also lets you launch things. It's kind of a super run as, and also includes capability to let you run as the system account. So now I'm in the system accounts folder, and that's exactly what I did, is I copied my lock screen over that one, and voila. Now I already peed in, lock screen comes on, it's my Windows Azure lock screen, and I was really proud of myself, and I told everybody for 3 days. In fact, I went home for dinner that night, and I told my wife and daughter at the dinner table, I was like, you will not believe what I did today at work. And my wife's like, after I tell her, she's got this puzzled look on her face. I'm like, what? She goes, why did you do that? Why did you go to all that trouble? I said, because I really wanted my Windows Azure lock screen. She goes, no, why didn't you apply this group policy that was added in December that lets you do that without having to do that crazy stuff? So I was really embarrassed in front of my daughter, so I sent her to her room and made her do process monitor exercises to distract her. Anyway, so that was that case. All right, now, are you convinced? All right, well, let's give it a shot. 1, 2, 3. When in doubt, run process monitor. All right, that's getting a lot better. Let's switch gears a little bit. Let's talk about application crashes. How many people have had an application crash? Just kidding, don't even bother. All right, this case, this is a user that's at a corporation, and they're running into this situation where IE crashes every time they hit the favorites bar, the favorites menu item. They ran IE, it was IE8. They ran it without add-ons. First thing you do is, hey, get rid of the third-party stuff. Still happened. Upgrade to IE9. Try it. Still happens. Runs IE9 without add-ons. Still happens. At this point, I don't know why they just didn't switch to Chrome, but I have to appreciate. But I honor their commitment to Microsoft technologies, and IE is just that awesome that they wanted to keep on going, and so they contacted Microsoft support. And so Microsoft support gets involved, and the first thing they do is they say, we need to capture a dump of IE so we can look at what's going on. Here's the IE process tree. This child is the one that's crashing. And in fact, let's see if I can make that happen on my IE, where there's IE. If I go to favorites, uh-oh. That wasn't supposed to happen. No, just kidding. It was supposed to happen. But the same thing's happening on my system. So how did they fix this? So to capture a dump of Process Explorer when it crashes, they used a tool called procdump. In fact, this person that did this, solved this exercise, actually has added a lot to procdump. He's in support, Andrew Richards. And the way that you run it is you specify, to look at a first chance exception, which is a crash like that, is you specify the -E switch and then the name of the process or the process ID if it's ambiguous of the process you want to capture the dump for. So I'm not going to actually show that here. This is what he did, and when he then went to Explorer's favorites, procdump, saw the crash, reported the exception, and then generated a crash dump file. Procdump is actually kind of a cool tool because I originally wrote it for support because they ran into so many situations where customers would have CPU spikes And the support couldn't get a dump of when this process was spiking to actually see what threads were active inside of it causing the dump. So let's take a look. Proc dump. I'm going to use CPU stress, little tool that consumes CPU. And I'll say proc dump. And it's got a whole bunch of switches. I'm going to say when CPU usage goes above 25% for CPU stress.exe, capture a dump. And now we can, and by default, it's going to do that for 10 seconds. And you can see after, if I switch this down to lower CPU usage, I just missed the threshold. But after 10 seconds, above 25%, proc dump's going to capture a dump, and then we'll be able to go look at it in WinDebug, which is the next tool we're going to look at, and see what's causing the crash. And there it goes. So that's what he did. And he took a look at the dump. And what he saw here in his dump was this function. Again, he'd configured symbols, and he saw order item compare. So he's thinking there's some kind of sorting going on. Perhaps it's like order of things in the favorites folder. So he goes to the favorites folder, and he looks through it, and he sees, oh, well, maybe it's these funny characters here that are throwing it off. So he deletes that thing, deletes that one. We actually moved the favorites to deleted that thing, still crashed, moved the favorites completely to another folder, still crashed. So what did he do then? He ran process monitor. Yeah, you guessed it. He ran process monitor, and let's take a look at his trace. And he set a filter to just capture registry activity because he figured out how to be a registry activity, and he searched for favorites because he figured maybe it's a registry key that has something to do with favorites. And he came across this. Actually, I should have set a little shortcut. I should have set a bookmark favorites order. He came across this. Favorites order. That has something to do with sorting. And it's reading some binary value there. And so he said, I wonder what happens if I go and reset that. And so he did a jump to. Actually, a jump to is only going to work if I'm elevated. So let's go and, oh crap, didn't mean to do that. Let's go and take a quick look. And there's the order key. You can see that I've already set this up. But what I'm going to do is just delete that, which is what he did. Come back to IE and click on favorites, and then voila, the problem's gone. So something had corrupted that registry value that had something to do with the ordering of the favorites in that. Now you can see that my favorites weren't actually impacted because the favorites are actually coming from that favorites folder. It's just that that function stores the sort order that I want in that registry value, and somehow that had gotten corrupted, but the problem was fixed by him changing or deleting that key so that it could get refreshed from scratch and not be corrupted, and the problem was solved for the customer. All right, now are you ready? One last time. 1, 2, 3, when in doubt, run process monitor. That side didn't, that's still the lame side over here, but nothing? Still not convinced? Okay, you're convinced. All right. All right, last section, blue screens. How many people have seen, no, I'm just kidding. I'm not going to. All right, anybody seen a blue screen in the last week? Wow, that's disappointing. Anybody seen a Windows 8 blue screen? Has anybody downloaded the Windows 8.1 preview? Has anybody seen a Windows 8. I'm afraid to ask. A Windows 8.1 preview blue screen? What? Yes? That's a yes over there? Wow. Like I was going to say that Windows has gotten so much more reliable that it's actually not Windows' fault. It's third parties. It's always third parties. But so what happens is, of course, why does Windows blue screen in the first place? It blue screens because it's trying to save your data. Something's gone terribly wrong in kernel mode, and in kernel mode, software has full access to all of the data in RAM, potentially hardware devices, everything on disk, and if it's misbehaving, it can actually end up corrupting your SQL database, corrupting your PowerPoint files, corrupting your Word documents. So Windows needs to stop the execution of that thing as quickly as possible, and the only way to do that is to shut down the machine and let you know that it's detected something's gone wrong. How many people have seen a blue screen in the public, in the wild? So quite a few of you. And those of you that have seen my Case of the Unexplained have seen some of my collections. I've got some of my collection to share with you. His luggage is not coming anytime soon, I don't think. This is the metro station in New York City. This is where you buy your tickets, the ticket vending machine. I think they just upgraded them, but this is about 6 months ago. It's running NT4, and then it blue screened too. So that NT4 splash screen was after the reboot, the automatic reboot. So I was able to get you nice free tickets up until about 6 months ago for the metro system in New York City, but now they've upgraded, so I can't. Here's a billboard. CompUSA's bestseller, which is why they went out of business, I think. Concert. This guy thinks it's actually part of his act. He thinks it's kind of cool and hip, I guess, to have blue screen as part of your techno light show. This is Dave Solomon, my co-author on Windows internals. This is at the airport, and I think it's Kennedy. And his wife's taking this picture of him. Dave's got a really pleased expression on his face because he's figured out the cause of the blue screens, told everybody in the waiting room. Airports are just blue screen magnet. Here's a floor that's blue screened. Here's a gas station pump that is blue screen. And I actually can't hold it against it because of this. Actually, they're completely unrelated pictures, but they go well together. This is actually a car sitting in the Building 26 parking lot at Microsoft. I think it's the Task Manager developer's car. This is a mall. It's a conference room at Microsoft. We see this a lot, upside-down blue screens there. A Surface, the old kind of Surface. I don't know what we call those anymore. Maybe legacy Surfaces. This is the most public blue screen ever. Last time I gave this talk, some people had actually seen this live and seen the blue. Anybody see this live and go, "Oh, look, there's a blue screen"? This is there's a close-up of it. There is a far away view of it. This is at the Beijing opening ceremonies for the Olympics, and there it is on the top inside of that bird's nest arena. Speaking of Olympics, anybody recognize this? It's Olympic Park in London. Big sign on the way in, blue screen last summer. Another one in Paddington Station. That train will not be arriving on time. Would you like a blue screen with your burger? This is a Ukrainian airport. How many people fly Ukrainian Airlines? Try to avoid that one. Here's Walmart's new MasterCard program. And then this one is just an oldie but goodie. In any case, let's get back to this. So this case, a customer or a user was complaining that their Windows 8 system would crash when running IE. And it's actually unfair to blame IE for crashes. I mean, it's mostly Outlook's fault. I'm just kidding. It's not Outlook's fault. But you can't crash the system from a user mode process. It's the permissions, the controls prevent a user mode process from reaching into kernel mode and causing the conditions for a blue screen. Now, what can happen, though, is that something in kernel mode can be triggered to execute a certain code path that does cause the blue screen because user mode is doing something, but user mode can't directly do it. So the administrator analyzed the dump file. I've got the dump file here. And analyzing a dump file, let's talk about how you find the dump file in the first place. Well, first, I've installed debugging tools for Windows. Second, I've configured the debugging tools for Windows symbol server over here in Files, symbol file path. You can see it's the exact same thing that I had in Process Explorer's configuration, which I also had in Process Monitors. And now I need to find the dump file. The easy rule of thumb for finding the dump file is just go to the Windows directory. If there's a memory.dump there, that's what you want. Now, if it's a system that doesn't generate a full dump or a kernel dump, go to the mini-dumps directory and pull the most recent mini-dump. And that's the rule of thumb. You'll always find a blue crash dump that you can analyze. Next thing, open the crash dump file. Once you load it, you'll see it starts to load kernel symbols. And it's going to pop out with some text about what the stop code was. And then it's going to have a hyperlink, which we're going to click, Analyze-V. Always click that. For detailed debugging information, this is just taking a while to, it's trying to pull symbols from the web. And any second now, we're going to see it pop out with its analysis. And this is literally how easy it is to do just a basic crash dump analysis, because the Bang Analyze uses a whole bunch of heuristics itself to look at what the thread was doing at the time of the crash, what the threads on the processors were doing, looks at the stacks of those threads, again, following the stack, and hopefully this will come up here in a second. And what it does when it looks at the stack is it weights, it's actually, I'm not sure I'm very comfortable with it. It's kind of like racial profiling. It says, oh, this is a Microsoft module. Well, it's probably not our fault. This is a Microsoft module. Probably not our fault. Ooh, third-party module. Probably that guy's fault. And in this case, I'll just jump right to the, I've got a picture of it in the slide. Right here, this is what we're going to see pop out of it, where it says, probably caused by this guy, which ASW.NET, that is Avast antivirus, its driver. And so what this user did was went to Avast's website and did a search for Windows 8, IE, BSOD, and they came across this article right here. New program update. Hi, we've just released an update. Fixes a bunch of things. Crashes, freezes, Windows 8 BSOD, and this is not very encouraging, but still investigating some issues. So, yeah, we think this is going to fix it, but maybe you're still going to have problems. In any case, what he did was installed the update that he got off the website here, and then the problem went away. No more crashes when run IE. So that brings me to the conclusion of the talk. Now, I'm right at the time limit here. I'm going to show you one more thing, which, if you want to stay, because it's lunch, right? We're burning into lunch. I'm keeping you from lunch. But I want to show you one thing. Would you like, if you haven't seen a Windows 8 blue screen of death, I want to show you one right here. Well, actually, SysInternal's book. I'm doing a book signing, by the way, at 2 o'clock. So if you want to come by and buy a SysInternal's book. But here's the Windows 8 blue screen of death. How many people have seen the Windows 8.1 blue screen of death? Because, you know, one of the things we've done is spend a lot of time looking at how we connect with users and making sure that we're listening to their feedback. And so what we realized is that the modern hip users thought that this was just not cool enough. To, you know, we tried with the unsmiley face to like, hey, sorry about that. But it really wasn't resonating with the teenage people. So we've updated in Windows 8.1. If you haven't seen it, this is what it looks like. So I'm going to do one more thing, and that is, would you like to see a blue screen, my system blue screen with a color that's not blue? You like to pick the color? I'll show you that. So let me just shut everything down. And that's the last thing I'm going to do before I end. And while I'm doing this, getting ready here, I want to say thanks for coming. I hope you had a great TechEd. There's one more session slot, I think, after lunch. I hope you have a great trip back to wherever you came from. Please, if you solve a case, send it to me so I can add it to my collection. Screenshots, log files, the more evidence that you've got, the better. I can share it with other audiences in the future. And please fill out an evaluation. Okay, now let's get started. I'm going to run Windows Debugger, and I'm going to do it in local debug mode, which lets me, I had to boot the machine debug, and this, what it does is let me modify the machine in real time. And there's a function called BSOD bug check, which is deep inside the bug check code. And right here, it is the function call to clear the screen and color it with the blue screen of death color. This function gets its color from this register right here, ECX. And this assembly language instruction is getting ECX's value from RDX. RDX is coming from here. And RDX is coming from this RCX register, which is set from right here, which is coming from that variable right here. Unfortunately, to set the blue screen color, I've got to chase down that location in memory. So let's go chase down where that color is coming from. And the way that I'm going to do that is by doing DQS POI that plus 18, and then this plus 28. And there's the color right here. The high byte is FF, but here's the color, 2067B2. And if I do a dB on that, we'll see the actual bytes. And if we open up MS Paint and we go to Custom Configure Color, and we say, what is that in decimal? B2, 67, and 20. It's 178. And it's actually blue first. So 178, 103, and 32. And there's the blue screen of death color right there. What color would you like? Red? Red's kind of boring. Here, how about you make noise as I move this over? Higher? Lower? Green? Do you like that color? That color? All right. So we need to translate that back into hexadecimal. I've got a little tool here, Hexadec, which I wrote, hex 48. I didn't write it just for this, by the way. And then blue is 0, 0, 0. Okay, so we've got now the EB, and the first color was the B2, which is the blue, and blue was 0. And green was 210, which is D2. And then the red was 30. Right? 30? Yeah, 30. All right, let's just take a look at our handiwork. And there it is, 0. Okay, now we're ready to blue screen the machine, or whatever color that is. And here we go. And this is not going to show up on the monitor, so I'm going to disconnect everything. Oh, actually, before I disconnect, let me show you Not My Fault. There's a tool called Not My Fault that I wrote. Because if you crash your machine with it, it's not my fault. It's actually a little tool. If you look at Windows internals, it's a tool that I wrote for demonstrating crash dump analysis, and with a whole bunch of different ways to crash your machine. And the way that we're going to crash it is just to say crash, because we don't care which way. So when I say crash, it's going to crash into this color, and then there we go.